So now that we've gone over the structure and functionality of the Handey microservice, let's take a look at its implementation. And what we'll see here is we're going to focus on the controller and the service and the repository classes. And we'll also take a look at how they're configured using a YAML file. And as I mentioned before, this implementation uses the R2DBC reactive database framework extensively. And you can find the implementation here at this link. So we're back in my IntelliJ project, and now we're going to take a look at the Handey Microservices module that's part of the EX3 project. So let's go ahead and start here by taking a look at the Handey application, controller, and service. Not a lot of surprises here, so I'm not going to dwell on this. We've covered this before. We're annotating this as a Spring Boot application, so it's a microservice. We say, go scan the quote class to get the entity that's used to describe the database. We say, here, let's turn this into an R2DBC repository using this particular class, and then we run the application. And down here is a little helpful bean, which if we uncomment the bean annotation, will go ahead and automatically run this method once this particular microservice is started up. And you can see what it does. It's kind of fun. What it does is it goes and it looks up all the items in the repository by their ID. So in this case, we're just going to look up a list of a couple of them. We don't have to do them all. We could do them all if we wanted to. And then we go ahead and subscribe ourselves to get those things printed out. So this can be kind of useful if you want a debugging mechanism to see that your program is working properly when it starts to run. But it doesn't actually send anything back to the client. Speaking of things that communicate with the client, here's the controller. This does what it normally does. As we talked about before, it's a REST controller with a couple of fields. It's got this info method that can be used to inform the Eureka discovery service that we're still up and running. And it's got a bunch of methods that are endpoint handler methods to get all the quotes reactively, to get the quotes that are listed by ID reactively, to search for quotes where they match all the quotes, and then search for the quotes where they'll match any of the quotes. Oh, I take it back. This is the one that does all, and this is the one that does any. So you can see that those are basically just a bunch of facades that handle the mapping from HTTP into Java types, and then we turn around and we forward these things onto the service. You notice that these two methods are post mappings, so they have to get the list out of the body. And this method up here is also a post mapping, so it gets the list out of the body. And this is a get mapping because we're just returning all the elements, so we don't have to pass anything in. In general, if you try to do things like pass lists in as parameters, you should really send those as post requests. There's ways to send them as parameters that you pass to the get request, but that gets kind of messy. And the last thing we've got here from the kind of the microservice implementation point of view, the top level items, we have the Handey service, which is auto-wired to the reactive quote repository. And we've got get all quotes, we've got post quotes, we've got search, and search EX. And you can see those all just go ahead and forward to the underlying repository methods. As I mentioned before, I could completely get rid of this class, probably should get rid of this class, and just have the controller auto-wired to the repository and then have it just forward to that. The service really isn't providing any additional value here whatsoever. Let's now go take a look at the repository side of things. So you can see that this is the reactive quote repository, which extends reactive CRUD repository and multi-query repository. And it's got this method which has the Spring Data API keywords in it to find the quotes containing the query ignoring case. So that's already provided for you. You don't have to do anything to get that to work. Here are the two methods that we had to implement to do custom queries that don't work out of the box with the Spring Data API. And like I said, they've got very long-winded titles: find all by quote containing ignore case all in, and find all by quote containing ignore case any in. And these two methods are then implemented by the multi-query repository impl, which implements the multi-query repository interface. As we saw before, here's the field that will be auto-wired to the database client. And now here are the implementation methods. And these are important methods to understand because your next programming assignment is going to be using these approaches very much in the same sort of way. So what have we got here? Well, we've got this call that takes a list of queries as strings, and we call a little helper method we wrote called build query string. And we pass in a portion of a select statement, select all from the quote table where the lowercase quote column or quote field is like this placeholder called params. And this placeholder like params is going to be basically expanded from a combination of this so-called where filter and the list of queries. And we're going to see how that's going to work in a second. The main thing I want you to notice, however, is we have this and here. So this is anding all of these things together so that it'll only get a match in the database if they all match, if all the queries match. So let's go take a look at build query string. This is a little helper method I wrote that is very convenient. And you can see what it does here is it comes down here and it goes ahead and will first take the where filter and the list of queries, and it'll use the join method. And the join method is going to go ahead and join these things together. So it's going to take the where filter, which is essentially this thing up here, and it's going to go ahead and basically fill in the queries one at a time after that where filter. So it's basically going to have each of these things occur with whatever we're searching for. So we're going to be searching for whatever we're searching for. These are the queries that are passed in. So that'll be turned into an expanded parameter string. So we then take that expanded parameter string with the appropriate syntax in here to tell it to do wildcard searching, something akin to regular expressions in database queries. And then we're going to update the SQL string, which was also passed in as a parameter, by replacing the params placeholder with the expanded parameters. And so what that's basically going to do is it's going to create a longer string that's going to be something like select star from the quote table where the lowercase quote is like, and then we're going to put in each of those different query strings. So quote is like, the phrase, this is a Handey quote, mankind, or humor, or laughter, or whatever it is the quote word we're looking for. And they're all going to be strung together. Now, up here you can see that this is the one that's building for the and version. We've also got one that builds for the or version, but this is building for the and version. So after we've got our query string, we're then going to call the getQuoteFlux method. And what this does is it uses our database client field to take that SQL string and say, I want to use this as the string to execute the query on. So that'll go ahead and set the query that will be executed. And then what we're going to do is we're going to use the map method. Now, this is just the good old map method that we would normally be accustomed to working on fluxes. And what that's going to do is it's going to take the result that comes back from doing the query with that query string. And for each row that comes back, we're going to create a new quote object where the first field in the quote object from the constructor is going to be the value of its ID, which is a number like 0, 1, 2, 3, 4, 5, up to the total number of quotes minus 1. And we're going to use that ArrayUtils obj to number helper method. And we looked at this before. It's basically going to take what we get, which is this object that comes back from row get ID. ID is the name of the field. And it's going to go get that object. And because of the way that R2DBC works, we can't use that directly as an integer. We have to use our little helper method to say, please try to convert that value into an integer. Now, mercifully, that will work fine because it is in fact an integer. And so it'll work, but we have to do that conversion. So that's where we get the value of the ID. And then the next thing we do is we also take the row, which we got back up here, and then we go look up the quote value. So this is the quote field that is stored as a string. Now, mercifully, R2DBC will in fact convert fields that are strings into strings. You don't have to do anything special there. So we just say string.class, but we have to write our own little converter here for integer or other types. The final thing we do is we use the .all method, and the .all method doesn't block, but instead it'll return the quote objects as they appear from the database query, and will then stream them back to the client. So the client will get this stream of fluxes that come back from that. So that's basically how we do the the first of the methods here, which is the one that's the find all by quote containing ignore case all in. And then the other method we have, which is find all by quote containing ignore case any in, is pretty much identical. The only difference is that the where filter we give here has an or in it rather than an and. So of course that's going to match anything that matches any of the query strings, not all of them. But otherwise, build query is the same as we looked at before. We're just reusing that method. And get quote flux is the same as before. We're just reusing that method. And the only thing that's changing really is the where filter. So that's essentially the implementation of the code part. Let's take a quick look, however, at the resources portion. This is the part where we configure the database. So schema.sql basically says create the quote table if it doesn't exist in the database already. And it's got a field that's an ID field or a column, which is the primary key. It's basically a serial number, which means it gets incremented every time it's initialized. And then we also create a quote field, which is a character array of no more than 1024 bytes or characters. That's not null. And 1024 is just the value that we have here in order to ensure that it is big enough to hold any of our quotes, either zippy quotes or handy quotes. Up here, we have the data.sql file. This goes ahead and has an insert that will insert all the values here into the quote database. And you can see it's going to be ID followed by quote. The ID is always default, because that's what we get when we do the auto increment serial behavior. So we get 0, 1, 2, 3, 4, 5, etc. for the names of the IDs or the numbers of the IDs. And then here is the actual quote that corresponds to each of those IDs. And these are just a whole bunch of Jack Handey quotes, which if you've ever watched Saturday Night Live, they used to have a bit where they would read these things, and they're pretty funny. The last piece of the puzzle here is our application YAML file, and this defines the port number that the Handey microservice listens on, which is port number 0, which says to Eureka, you select the port number. And then we tell it, hey, Eureka, I'm a Eureka client, so that means that it will keep track of my port number that it assigns for me and how to contact me. We give it the name, which is the Handey application. And then we go ahead here and we define where the data source is. And you can see the data source is going to be the R2DBC database controller or database connector. And it's going to be an in-memory database with a couple of options here. We define what the password and username are, which we don't care about because it's just a simple test case. And then we can also define some ways of being able to debug this particular database on the console as well. So that's basically the implementation of the Handey microservice. Make sure you pay careful attention to this because it's got a lot of pieces that you'll need for your assignment 2C solution.